For this video, we're going to introduce one more type of line or segment that is part of a circle, all right? And then we're going to talk about and try to organize our thinking a little bit better for what are called angles of a circle and segments of a circle, all right? And our two objectives in this lesson is to be able to find any kind of angle when it's formed by chords, secants, or tangents, and to find the length of any segments that are associated with circles. All right, so the first thing we want to do, this is pretty easy. We're going to introduce a new line in a circle, which might look something like this, where it goes through the circle in two exact locations. All right, if we look at segment AB, we know that that's a chord. But if you talk about the line that creates that segment, okay, that line AB, is a secant. All right? So what we're going to do now is start to talk. Let's kind of review a little bit, talk about some new angles, and then kind of organize all of our thinking here. So where we've been so far with angles of a circle, if the vertex is in the center, it's called a central angle, and a central angle is equal to its intercepted arc. If the vertex is on the circle, then its measure is half its intercepted arc. So what are we going to do when it's floating around inside the vertex, or the vertex is floating around outside the circle? All right? And this first theorem says the measure of an angle formed by two lines that intersect inside of a circle. So let's kind of sketch that. We got a line here, and let's say that we have another line here. And those two lines will be called secants. All right? I'm going to call this angle 1. And I know that angle 1 has this arc AB as an intercepted arc. Let me just kind of sketch it on here. But it also has kind of like a secondary intercepted arc. And that would be this part back here, CD. So it's kind of got two little intercepted arcs. Here's what this one says. If the vertex of the angle is inside the circle, not in the center, but inside, all right, then I know that the measure of the angle is equal to half the arcs added together. Arc AB plus, I didn't mean to write that parenthesis there. Let me erase that real quick. Arc AB plus arc BC. All right. So when the vertex is floating around inside, I know that the angle is half the two arcs added together. The next theorem says, what if the angle is formed by something outside? All right, so the vertex is now outside. So let's say, for example, we have a secant and we have another secant. All right, that's telling me that the vertex is right there. Now, this also has 1 and 2 intercepted arcs. I'm going to call those arcs A, B, C, D. And what this is telling me, let's call this angle 1 again. I know that the measurement of angle 1 is going to be half the difference of the measures of the intercepted arcs. So this would be half of arc CD minus arc AB. All right? So let's kind of organize and summarize everything that we know about angles. All right? Everything that we know about the angles is based on the vertex and where the vertex is located. If the vertex is at the center, then what we do, its measure here would be the arc. If the vertex is on, also known as an inscribed angle, then its measure is half the arc. if the vertex is in or inside, floating around somewhere, not in the center, then it's equal to half of the arcs added together. So make sure you know what that means, the intercepted arcs added together. And then if the vertex is out, its measure is going to be half of the difference of the arcs. Make sure you know which one you're going to subtract. Obviously, if I subtract and I get a negative, that can't happen. This is the key to angles and arcs. Make sure that you understand that. Let me know if you have questions. All right, so I look at this first example here. I notice the vertex is out. If the vertex is out, I know that the angle will be half the intercepted arcs subtracted. Literally, it's that easy. So then x would be half of, 92? So then x is going to be 46 degrees. All right, take a look at this. I know that x is an arc in this case, but its arc is part of this angle. That angle has a vertex out. So what do I know? I know that that angle is equal to half of the arcs, its intercepted arcs, subtracted. In this case, it would be 160 minus x. Now, what I would recommend doing here is multiply the left side by 2 to make that 1/2 go away. So I've got 100 is equal to 160 minus x. Subtract 160, I get negative 60 is negative x, or x is equal to 60. Now to find y, that's a different scenario. Its vertex is on. If it's on, the angle is half of its arc. Ooh, but I got a little question mark. I don't know its arc. Well, let's see. We can figure it out here. All right. I know that the arc over here, the given is 160. I just found x to be 60. So that's 220. I know one trip all the way around the circle is 360. So if I subtract that, I get 140 is this arc. And therefore, the angle would be half of 140, or the angle would be 70 degrees. Okay, take a look at this next scenario. So we have a vertex out. We're given one of the angles is 120, one of the arcs is 120. If that arc is 120, I know that this arc is 240, because 120 plus 240 would add up to 360. All right, so I know x is going to be half the difference, 240 minus 120, or x is going to be half of 120, so x is going to be 60 degrees. All right, let's take a look at this next one. All right, let's find x first. I know that x right here is formed by two intersecting arcs added together. All right, I know that one of its intercepted arcs, if you look on the same side of the circle as x, one of its intercepted arcs is 180. So I'm going to go ahead and start writing this. X is equal to half of 180 plus, I'm adding because the vertex is inside. And in order to add it, I need to know what this little arc piece is right here. Well, I know that 70 and 60 add up to 130. I know this segment, this chord right here, is a diameter. All right, that's how I got the 180. So if I know that, I know that this has to be 50. There's my other piece. I know x is half of 230, which tells me that x is 115 degrees. Now, to find y, all right, y is an arc. Its vertex that's associated with it is outside. All right, I know that 53, the angle, is equal to half of its intercepted arcs subtracted. Now again, the endpoints of that angle whose vertex is outside are a semicircle, 180, and I have to subtract what I'm trying to find there, y, from that. Again, I like to double the 53 to get rid of that 1/2, so 106 is equal to 180 minus y. Subtract 180, I get negative 74 is negative y, or y is 74 degrees. All right? The second thing that we have to focus on for today's lesson is what about finding segments here? Now, this takes a lot of practice here, guys. All right, I'm going to do my best to describe it to you, but I'll be honest with you, it is easier if I were in a classroom with you. You just got to put some work into this. All right, everything is still dependent on the vertex. Now, there are 3 specific scenarios about segments that we can connect to the vertex. All right, first scenario is if the vertex is in. The way I want you to think about it is I know that the equation that we can create here is start on one of the chords in this case. All right, and I know to get from that chord to the edge and from that intersection to that edge. So from that point of intersection to get to one edge and to the other edge, that's our A times B. It has to be equal to, now jump on the other chord and do the same thing. How do I get to one edge? How do I get to the other edge? Multiply them together. And that's how we come up with that equation. All right? So we're going to have known information in there to create an algebraic equation to solve. Now in the second scenario, the vertex is out. No problem. Here's the way I like to think about it. The first thing I'm going to do is measure to the circle. That's our W. Then I'm going to measure to the other side of the circle. That's where this W plus X comes into play. Measure to the other side. Measure, same thing for the other axis here. Measure to, there's Y. Measure from P to the other side. That's Y plus Z. And that's how this equation gets created. The third scenario would be, what if you have a tangent chord or a tangent secant relationship? All right. I'm going to measure to the circle and to the other side of the circle. Well, for a tangent, it's the same thing. I'm going to measure on this secant to the circle, there's our Y, and to the other side of the circle, that's Y plus Z. And fellas, I do understand this is pretty difficult to wrap your head around. Might not be a bad idea to go look at some other videos on the internet to kind of help you. All right. Hopefully my explanation on these examples will make sense to you. All right. So we've got 2 scenarios. Vertex in or vertex out. If the vertex is in, then I know 8 times X is equal to 20 times 6. Stop for a second and think about how I did that. From the vertex, I went to the circle times to the other side of the circle on a chord. Then I did to the circle to the other side of the circle on the other chord. That creates an equation. I know that 8x is equal to 120, which means that x would be equal to 15. Done. All right, take a look at this scenario. Vertex out. This is what's called a secant-secant relationship. I'm going to measure to the circle, 11, and then to the other side of the circle, which would be 11 plus 20, and that equals to the circle, 13, times to the other side of the circle, which would be 13 plus C. All right, so I get 121 is equal to 121 plus 220 equals 169 plus 13C. This is the algebraic equation I have to solve. So let's see, we got 341 is equal to 169 plus 13c. And I noticed previously it said, if you do get a decimal, round to the nearest tenth. Let's see, I'm going to cheat with the calculator here. I've got 341 minus 169. That's 172 is 13c. And then divide that by 13. All right, and I get this decimal 13.2. So I know that c is approximately equal to 13.2. All right, let's take a look at this scenario. All right, let's see. I want to first use this angle kind of on the bottom in order to find x. So here's how we're going to do it. You ready? We're going to start with this bottom one. Vertex is out. 7 to get to the circle. 7 plus 15 to get to the other side of the circle equals 5 to get to the circle times 5 plus x to get to the other side of the circle. All right, so this would be 7 times 22, which would be 154, is equal to 25 plus 5x. I'm going to subtract 25 and then divide by 5. And I get that x is 25.8. Now I need to find y. Y is a tangent. I want to use that tangent, but I also want to come back and use this because it's given information. All right, so I know y times y, or y squared, is equal to 7 times 7 plus 15. Or y squared would equal to 154. If I take the square root of 154, I'm going to get 12 point something. 154 square root 12.4, and that's y. All right, our last scenario here. Let's see here. All right, I know there's the vertex. All right. To find x, I want to use this and this. All right? So here's what I know. 11 times 11 is equal to 7 times 7 plus x plus 5. All right? So the vertex was out. I used the information, and now I have an equation with just one variable. So this would be 121 is equal to 7 times x plus 12, or 121, I should say, is equal to 7x plus 84. If I subtract 84, 121 minus 84, I get 37 is equal to 7x. And then if I divide 37 by 7, I get 5.3 rounded correctly. 5.3. All right. Now, to find y, I have to use 5.3. And the reason being, let me kind of erase some of these marks here. The reason being is because the vertex here is in. So that means that I have to use these two interior segments. They're also known as chords. All right, so let's try to write this up now. I have 9 times y is equal to 5 times x, but I'm going to use the approximation of x, 5.3. 9y is equal to 5.3 times 5, which would be 26.5. Divide that by 9. So 26.5. And then if I divide it by 9, sorry, it was 2.9. All right. The only exception, guys, might be that they want you to use what this decimal approximation was up here without it being approximated. So if you try it on Math Excel, if you get a problem like this on Math Excel, all right, and you do exactly like we do, and the answer 2.9 they say is wrong, chances are this 5.3 up here that we use the approximation for, they're not using that approximation. So I would literally want to have 37 divided by 7. Okay? Hope this helps. Let me know if you have any questions.